We want to use a double integral to find the volume of a tetrahedron defined by z equals 12 minus 3x minus 2y, where x, y, and z all bigger than or equal to 0. So what do we need to do first? We can see the plane, right? The plane is here, and I am interested in that portion of that plane that lives in the first octant, where x, y, and z are all positive. So this is in essence what we are looking for. This is that tetrahedron. So if I integrate over that base is what? That base is a triangle. Essentially looks like this. If I integrate that plane, the equation of that plane, over that base, that will give me the volume of that tetrahedron. That's what we're looking at. So let's consider what that base would have to be. The base sits in the xy plane. That happens when what? What must be true? XY plane? Z has to be 0. So if z is 0, we are at 0 equals 12 minus 3x minus 2y, 3x plus 2y equals 12. And let's consider the intercepts. What are we going to have? If x is 0, y would have to be 6. 2 times 6 is 12. If y is 0, x would have to be 4. So if we're going to visualize this, what do we have? 0, 6, and 4, 0. We're here. And we have our borders. Our southern border is here, is y equals 0. Our western border would be x equals 0. And the border on the side, of course, is that line being 12 minus 3x minus 2y equals 0, or 3x plus 2y equals 12. So if I'm solving this, then 2y equals negative 3x plus 12. Y is dividing by 2. Negative 3 halves x plus 6. So that's this border. Negative 3 halves x plus 6. So how do we determine the volume of that tetrahedron? What will that volume be? Well, let's go south to north. So the southern boundary is y equals 0. And the northern boundary is y equals negative 3 halves x plus 6. So that has to be a dy here. And then what does x range from? Lowest x value I see to the highest x value I see. That point, of course, is 4, 0. So the lowest x value I see is 0. And the highest x value I see is 4. So that has to be a dx on the backside. And the function I'm integrating is that plane that is constructing that tetrahedron. So I'm integrating 12 minus 3x minus 2y over that region. That will give us the volume of the tetrahedron. So let's look at that double integral. The first step is to look at the inner integral, and the antiderivative of that with respect to y will be 12y minus 3xy minus y squared, as y ranges from 0 to negative 3 halves x plus 6. So let's plug those values in. And replacing all of the y's first with negative 3 halves x plus 6, and then with 0. But if there's 0, we get 0 minus 0 minus 0, so that's not terribly interesting. Now it's time to go ahead and simplify the algebra. What do we get there? Looking at this, 12 times negative 3 halves, negative 18x. 12 times 6, 72. Negative 3x times negative 3 halves x, 9 halves x squared. Negative 3x times 6, negative 18x. Negative 3 halves x plus 6 squared, 9 quarters x squared, 36 here. Twice the first times the second, negative 18x here. Now we need to look for like terms. So let's do that. First off, we see 9/2 x squared minus 9/4 x squared, which will be 9/4 x squared. Next, we see negative 18x minus 18x minus negative 18x, which of course is just plus 18x, and that will result in minus 18x. And looking for our constants, we see 72 minus 36 will give me plus 36. That is my inner integral. So that will replace everything in here. So that what will our volume be? Our volume will be the integral as x goes from 0 to 4 of that inner integral, 9/4 x squared minus 18x plus 36 dx. So one more integral to do, and that'll give us the volume of that tetrahedron. So integrating that, we get 9/4 x cubed over 3 minus 18 x squared over 2 plus 36x as x ranges from 0 to 4. And then as we see, simplifying the algebra, we get 3/4 x cubed minus 9x squared plus 36x evaluated as x goes from 0 to 4. Plugging in those 4s, again, 3/4 times 4 cubed minus 9 times 4 squared plus 36 times 4 minus a bunch of zeros. What will that give me? 4 cubed over 4 is 4 squared. 16 times 3 is 48. 16 times 9, 144, plus 144, minus 0. So we get the volume of that tetrahedron is 48. Now, can we check that with rules from geometry? The thing to remember is the volume of a pyramid is 1/3 the area of the base times the height. Is a tetrahedron a pyramid? It is, because it has a base and everything comes together to a point. You know, even a cone works with this because the area of the base of a cone is pi r squared, right? And the height would be h. 1/3 pi r squared height is the volume of a cone. So it has a base, comes to a single point. That's in essence our definition of a pyramid. So what is our height for this thing? Looking at our picture, what do we see? We see f of xy is 12 minus 3x minus 2y. How high does it go? Well, the highest it goes is when x and y are 0. So the height of this thing is 12. So let's make that note. Now, what is the base again? The base is that triangle. Remember, x out to 4, y out to 6, and then connect those things. So let's take a look at our base. Again, x out to 4, y out to 6, but connect them. So this is a triangle, and the area of a triangle is 1/2 base times height. So that would be 1/2 of 4 times 6. So that's also 12. So then using our formula for the volume of a pyramid, we said is 1/3 area of the base times the height. In our example here, we're going to get 1/3 times 12, the area of our base, times the height, which is 12. 1/3 of 12 is 4, times 12 is 48, which is what we obtained using the double integral.